Alright, so we have completed 2 out of the 7 sections, and now we will be doing this third section, equations of lines, and we'll start with this theme, the basic concept of the slope and intercepts of a line. So here we have this straight line, and we'll talk about the slope of this line and the intercepts of this line. So let's actually first talk about the intercepts because that's actually a very straightforward idea. So if you look at where this line is intersecting the x-axis, it is this point over here, which is -2, 0. So the x-intercept of this line is simply the x-coordinate of this point of intersection, which is -2. So -2 is the x-intercept of this line. And similarly, what do you think will the y-intercept be? So let's look at where this line intersects the y-axis. So it intersects the y-axis at this point, which is 0, 1. So the y-coordinate of this point, which is 1, will be the y-intercept of this line. So that's it. The x-intercept is the x-coordinate of this point of intersection with the x-axis. The y-intercept is the y-coordinate of the point of intersection with the y-axis. Now let's talk about the slope of this line. So the slope of a line is a measure of its steepness. So let's see what that means. Let's take any 2 points on the line. So I'll take this point here, which is 2, 2, and let me take this point here, which is 6, 4, and now let me complete this right triangle like this. So as you can see, this horizontal distance over here, the difference between the x-coordinate 6 and 2, this will be 4. And this vertical distance over here, which will be the difference between the y-coordinates 4 and 2, this will be 2. So this right triangle has a height of 2 and a base of 4. So the steepness of this line can simply be measured as a ratio of this height over this base. And typically the slope of a line is represented by the letter m. So we'll say that m is simply 2 over 4, or I can simplify it to 1 over 2. Now there is a special terminology used for this vertical distance and this horizontal distance. So the vertical distance is called rise and the horizontal distance is called run. So what we see here is, and these terms are obvious because what these mean is, in this case, for example, for a run of 4, the line rises by 2. So that's how you can think about it. For a run of 4, the rise is 2, and now if you take that ratio 2 over 4, you get the slope of the line. So the slope of a line can simply be calculated like this. Take any 2 points on the line. We took these 2 points specifically 2, 2, 6, 4, but it wouldn't have mattered if we took some other pair of points. We can take any 2 points, find the corresponding run and rise, take that ratio, and we get the slope of the line. So in general, if we have any 2 points, let's say this point is x1, y1, and take another point here, x2, y2, and use these 2 points to find the rise and the run and the rise, and take the ratio, you will get the same value of the slope. So slope will always be rise over run. And to calculate its specific value, you can find the rise as the difference between the y-coordinates. So if we have y2 and y1, the difference is y2 minus y1, so that's the rise, so y2 minus y1. And the run can be calculated as the difference between the x-coordinates, x2 minus x1, so that's the run, x2 minus x1. And then we take this ratio, so y2 minus y1 over x2 minus x1. This is how you can calculate the slope of any line by taking any 2 points on it. Now, if we have a line that is slanting upwards from left to right like this, as you can see here, what do you think will be the slope of such a line, or what can you say about the slope of such a line? Well, if you think about it, if you take any 2 points on this line and calculate the corresponding run and rise, you will find that for this is the run and this is the rise, and the rise is positive for this run, and that will be true for any pair of points. For any run, you will get a positive rise because the line is actually rising towards the right, and therefore the slope m, which is rise over run will always be positive. So for a line that's slanting upward from left to right, the slope is always positive. But if you have a line that's slanting downwards from left to right, what can you say about the slope in this case? Well, once again, take any 2 points on the line, and now you can see that for this run, the rise will be negative because the line is actually falling down, so to say. So the rise is negative for a positive run, and therefore the slope m, which is rise over run, will in this case be negative. So for a downward slanting line, the slope is negative. And now if you have a horizontal line like this, what do you think the slope is in this case? So if you take any 2 points here and visualize the rise and run, you have some positive run, but the rise is 0 because the y coordinates of these 2 points are the same. So the difference is 0. So the rise is 0, and it's obvious visually that the line is not rising at all. So the slope, which is rise over run, what will this be? So because the rise is 0, the slope will be 0. So for any horizontal line, the slope will always be 0. And now, what do you think will happen in the case of a vertical line? What will be the slope in this case? So if you take any 2 points on this line, so let's say this is x1, y1, and this is x2, y2, but actually the x coordinate will be the same. So we can just call it x1, y2. There is some run. There is some rise, a positive rise, because you're going from y1 to y2, but the run is 0 because you have an x coordinate x1, here also you have the same x coordinate, so the run is 0, but there is a finite non-zero rise. So if you try to find the slope, which is rise over run, you have a finite number in the numerator but 0 in the denominator, so this quantity will be undefined. So for a vertical line, its slope is undefined. Now here is an SAT sampler on this concept. What is the value of a if the line that passes through a, 7 and 1, a has a slope of negative 5 over 9? So we are given these 2 points and told that the line that passes through these points has a slope of negative 5 over 9, and we have to find the value of a. So it's actually a very straightforward problem. We know that for any 2 points x1, y1 and x2, y2, the slope can simply be calculated as rise over run. So y2 minus y1 over x2 minus x1. So in this case, if we take this point as x1, y1 and this as x2, y2, then the numerator will be y2 minus y1, which is a minus 7. So a minus 7, and the denominator will be 1 minus a. Okay, so a minus 7 over 1 minus a. This should be equal to negative 5 over 9. So let me write this as negative 5 over 9. So now I have to solve this equation and find the value of a. So how can I do that? So I have to get rid of these denominators, 1 minus a on the left and 9 on the right. So I can do that in 2 steps. I can first multiply by 9 on both sides, and that will help me get rid of this 9. And then I can multiply by 1 minus a on both sides, and that will help me get rid of this denominator over here. And this will lead me to the equation. On the left side, I will get 9 times a minus 7, and on the right side, I will get negative 5 times 1 minus a. Alright, so now let's expand these parentheses. So 9 times a minus 7 will become 9a minus 63 is equal to negative 5 times 1 minus a will become negative 5, and then a positive 5a because you have 2 negative signs here. So now let's use balancing to combine like terms. So I have 9a over here, 5a over here. So let's subtract 5a on both sides. I will get 4a on the left side, and then let's add 63 on both sides. So I will get 4a is equal to 63 minus 5, which is 58. So 4a is equal to 58, and now I can finally divide by 4 on both sides, and that will give me a is equal to 58 over 4, which I can simplify to 29 over 2. So 29 over 2 is the value of a for which the line passing through those 2 points will have this slope of negative 5/9. Now here is our next SAT sampler. The line shown in the XY plane, this line over here, passes through the origin, this point, and point A comma B, where A is greater than B. Which of the following could be the slope of the line? Okay, so the origin is 0, 0, and then this point is A comma B. So the slope of this line, we can simply use y2 minus y1 over x2 minus 1, x1, rise over run, and find the slope of this line as the difference of the y coordinates. So b minus 0, that's b, over a minus 0, that's a. Alright, so the slope of this line is b over a. And now we can see that a comma b is in the first quadrant. So both a and b must be positive. And we are also told that a is greater than b. So if you think about this fraction over here, or this ratio over here, both the numerator and the denominator are positive, but the numerator is smaller than the denominator. So this ratio should turn out to be a fraction or a fractional quantity that is positive but less than 1. So let's see which of these terms would work. So negative fraction won't work. This is a positive fraction less than 1, so this would work. This is 1, exactly 1, so this won't work. And 3 over 2 also would not work, that's greater than 1. So the correct answer just by elimination is therefore 3 over 4. Our next theme in this section is different forms of a lines equation. And typically on the SAT, you will see two forms of a lines equation. The most common one will be the slope-intercept form, in which the equation of the line will be written like this: y is equal to mx plus b, where m is the slope of the line and b is the y-intercept of the line. And you can actually verify that this makes sense. If you put x equal to 0, you get y equal to b, and therefore the y-intercept should indeed be b. Okay, so that's the slope-intercept form. And then sometimes the equation of a line might also be written in the standard form, which is like this: ax plus by is equal to c. And if the equation is written in this form, then you can find the slope and the y-intercept and x-intercept using these expressions. Slope is negative a over b, y-intercept is c over b, x-intercept is c over a. Why do these expressions make sense? Let's quickly verify. Let's take the standard form, which is ax plus by is equal to c, and write this in the slope-intercept form and then see if those expressions are correct. So I need to isolate y on the left side. So let me use balancing. I'll subtract ax on both sides. So that gives me by is equal to negative ax plus c. And then I need to get rid of this b. So I'll divide by b on both sides. So that gives me y on the left is equal to negative a over b times x plus c over b. Okay. So what do you observe now? If you compare this equation with this equation, we see that the slope m is negative a over b, which is what is written over here, and the y-intercept small b is this expression, which is capital C over capital B, which is what you see over here. And then the x-intercept. How do we find the x-intercept? Well, for that you can substitute y equal to 0 in this original equation. So if you do that, you get ax is equal to c, or x will turn out to be c over a. So all of these expressions are indeed true. So that's the summary here. Slope-intercept form, y equal to mx plus b, and from here the slope and y-intercept are directly evident. And then you have the standard form ax plus by equal to c, and then you can use these expressions, or you can just use first principles like what we did here and find the slope and the intercepts. Now here's an SAT sampler on the slope-intercept form. Which of the following is the equation of the given line? So we are given this line here and we have to find out which of these is the equations of this line. So the slope-intercept form, as we know, is y is equal to mx plus b, and let's find b. So b is the y-intercept. So you can see the y coordinate of this point. This point is 0, 1. So the y coordinate is 1, which means that b is equal to 1. But what about the slope? So to find the slope, we can take any 2 points on the line. So let me take this point perhaps, which is negative 2, 4, and I could take maybe this point. So it doesn't matter, you can take any 2 points. So this point is 2 comma negative 2, and now I'll simply use the expression y2 minus y1 over x2 minus x1, or rise over run, to find the slope. So negative 2 minus 4 is negative 6, so that's the rise, and 2 minus negative 2, that's the run. So 2 minus negative 2 will be 4. So m is minus 6 over 4, which we can simplify to negative 6 over 4, which we can simplify to negative 3 over 2. So that's the slope, and we have the y-intercept 1. So the equation of the line will therefore be y is equal to negative 3 over 2 x plus b, or plus 1. So let's see which one of these is correct. So y is negative 3 over 2 x plus 1. So option D is the correct answer. Okay, here is our next problem now. The equation of a line is 3x minus 4y is equal to 17. So as you can notice, this equation is now in the standard form. If its x-intercept and y-intercept are m and n respectively, what's the value of m over n? So let's just use this equation, which is in the standard form, and find the x and y intercepts, which are m and n, and then calculate the ratio. So the equation is 3x minus 4y is 17. So first we will find the x-intercept, which is m. So x-intercept, which is m. To do that, we will substitute y equal to 0 into the equation. So we will get 3x is equal to 17. So 3x is equal to 17. Divide both sides by 3. You get x is equal to 17 over 3. So that's the x-intercept, which is m. So therefore the value of m is 17 over 3. And now let's calculate the y-intercept. So to calculate the y-intercept, we will substitute x equal to 0. So that will give us the y-intercept. For that, we'll substitute x equal to 0 into the equation, and that will give me negative 4y is equal to 17. So this means that if I divide both sides by negative 4, I can isolate y. Y will be equal to negative 17 over 4. So that's the y-intercept, which is n. So the value of n is negative 17 over 4. Now all we need to do is find m over n. So this fraction over this fraction. So let's just do that. So we need to find 17 over 3 divided by negative 17 over 4. So we can multiply by the reciprocal of this fraction. So we can write negative 4 over 17. I can do it this way, and these two terms cancel out, and I should be left with negative 4 over 3. So negative 4 over 3 should be the value of m over n, which is option A. So that's the correct answer. Now the last theme in this section is parallel and perpendicular lines. So suppose that we have two lines whose slopes are m1 and m2. Now here's the thing, if m1 is equal to m2, this will mean that those two lines are parallel. And this makes intuitive sense, because if the slopes are equal, it means that the steepness of the two lines must be equal, which means that they should be parallel. So m1 equal to m2 means that the two lines are parallel. And if one slope is the negative reciprocal of the other slope, so if m1 is negative 1 over m2, or if the product of the two slopes is equal to negative 1, this particular situation means that the two lines are perpendicular. And the proof of that does not really matter for the sake of our discussion. You just need to remember that if the product of the two slopes is negative 1, or if one slope is the negative reciprocal of the other slope, then that means that the two lines are perpendicular. So these are two really important results on slopes. If the slopes are equal, the lines are parallel. If the slopes have a product equal to negative 1, then the lines are perpendicular. Now here is an SAT sampler on parallel lines. Which of the following equations represents a line that is parallel to the line with equation y equal to negative 1 over 2x plus 5 and contains the point negative 2 comma half? So there is some line that is parallel to this line and also contains this point. Which of these four is that line? Alright, so we're looking for a line that is parallel to this line. So this line has a slope of negative 1 over 2. So the line we are trying to find should also have a slope of negative 1 over 2. So let's assume that the line we are looking for, its y-intercept is b. So we can write our line as, the line we seek as y is equal to negative 1 over 2x plus b. Now we are also told that the line contains this point negative 2 comma 1 over 2. So the coordinates of this point should satisfy this equation. So let's do that. So the y coordinate is 1 over 2. So let's plug it in place of y. So 1 over 2 is equal to, the x coordinate is negative 2. So let's plug it into in place of x. So negative 1 over 2 times negative 2 plus b. Alright, so what do we get here? So this product will be, the negative will multiply to a positive sign, and we have 1 over 2 times 2, that is 1. So this product will be 1. So we get 1 over 2 is equal to 1 plus b. So 1 over 2 is equal to 1 plus b. And now let's isolate b, subtract 1 on both sides. We get negative half, negative 1 over 2 on the left side is equal to b. So b is equal to negative 1 over 2. So now we should get our equation, y is equal to negative 1 over 2x plus negative 1 over 2. So we might need to simplify that because we don't have any fractions here. So let's do that. Our equation is negative 1 over 2x, and then b is also negative 1 over 2. So I'll write it like this. And now let me multiply both sides by 2 to get rid of the fractions. So I should get 2y is equal to negative x minus 1. So what I observe is that all of these options have the variable terms x, the x terms and the y terms on one side. So let me just do that with my equation as well. So let me add x on both sides. So that will give me x plus 2y on the left side and negative 1 on the right side. So from here I can go to x plus 2y on the left side is equal to negative 1 over on the right side. So this should be my equation, and this is option B. So that's the correct answer in this case. Okay, now here is an SAT sampler on perpendicular lines. Which of the following is the equation of a line that is perpendicular to the given line? So we have this line here, and we have to identify which of these lines will be perpendicular to this line. So the way we can solve this is find the slope of this line and then find which of the slopes of these lines here will make the line perpendicular to this line, using the result that for two perpendicular lines, their slopes are negative reciprocals of each other. Okay, so let's find the slope of this line first, and for that I will take any 2 points on the line. So let me take this point here, which is negative 3 comma 0, and let me take this point here, which is 0 comma negative 2. So the slope will be rise over run. So the difference of the y coordinates, minus 2, negative 2 minus 0 is negative 2. So that's the rise, and then 0 minus negative 3. So that's the run, which will be plus 3. So negative 2 over 3 is the slope of this line. So the slope of a line perpendicular to this line should be the negative reciprocal of this slope. So the negative reciprocal of this slope will be what? So this is negative 2 over 3. So its negative reciprocal will be positive 3 over 2. So what we have to do is find a line from these four options which has a slope of 3 over 2. So let's see. This line here has a slope of negative 2 over 3, doesn't work. This one has negative 3 over 2, doesn't work again. What about this one? So y is 3 over 2x minus 5. So yes, this indeed has a slope of 3 over 2. So this option is correct, and this has a slope of 2 over 3. So this is incorrect. So therefore option C is the correct option in this case.